This video compares the HolidayCoro Flex-based expansion system for controllers to the Falcon V3 system. Now, both of these controller systems are expansion-based systems. They are both 48 output or ports each, and they have similar common traits: OLED screen, buttons, network switches, outputs for SPI, fuses, and some power connectors. Now, how they implement those differences is an important key difference. First, let's talk about the actual thing that's driving the pixels. Now, there's some unique characteristics here because the HolidayCoro Flex system is very, very modular and was intended to solve some of the problems found in the Falcon system. Now, the Falcon controller comes with a controller with the CPU built in. So, this is actually two parts. So if you compare it to a HolidayCoro system, what you have here is the CPU portion at the top, and then you have the SPI portion at the bottom. HolidayCoro has separated these two pieces. Falcon has combined them together. So this means this is 1/3 of your output, 16 out of the 48. This means that this connector can be used for the remaining 17 through 42, or 48. Now, with the HolidayCoro system, you can see that there are 3 ports in both types of CPUs, and we'll talk about both types of CPUs in a moment. There are 3 ports, and that means you can hook up boards independently. This is a very key distinct difference. The HolidayCoro system allows you to have different types of CPUs. So, they offer a regular, standard, basic, low-cost CPU in the AlphaPix Evolution controller, and then a higher-end HinksPix Pro CPU. So you can choose and mix and match that together with different expansion boards. So let's talk a little bit about the different kinds of expansion and output options we have. So we'll come back to CPUs and compare those in a moment. First, let's look at the expansions of SPI. So here we have the 2 expansions, this one from Falcon, this one from HolidayCoro, and we see some differences. We see some differences in size. Now, this seems like this is better because it's smaller, and the HolidayCoro is larger. Now, there's some very good reasons for that. This is because with the Falcon system, these boards cannot stack. You don't stack these. What you do is you have boards like this, and you take a cable here, and you connect them together, let's see here, and you run them like this. Now this puts your cable in front of everything. They're not intended to stack, so the connections and the screw terminal portions don't line up. So it's not intended to be a stackable system, as where the HolidayCoro system is fully intended to be stackable. So if you look at the CPU, you'll see that the holes line up between the expansion board and the CPUs so that they always can be mounted on top of each other. And this allows us to use vertical height, as where the Falcon system uses a horizontal system. So this means you need a larger controller, and let's say, for example, here you want 32 outputs. That means that you need these cables to come above these cables, and that blocks all of your connections and makes the cables different lengths and a whole bunch of other issues. So HolidayCoro started from the beginning with a more stackable design. So let's go back to the SPI boards and see why that space difference is really not a problem. Why? Because the CPU is right there. So if you compare these 2 controllers, you'll actually see that when you stack a HolidayCoro SPI board with a CPU, it's vertical height, not horizontal, which is generally what you want in an enclosure, because enclosure usually is deeper and has a lot of room that's not used in a controller like this. So you really have a smaller controller footprint. Now, we'll show you assembled controllers in a moment here. So let's go back to the SPI boards. There's some other fundamental key differences. So one of them is that the ribbon cable has to be jumpered from one to another. So if you jump off of here, come off of here, and go on to the next, you have them layered over the top of each other. Now, one of the other problems with the Falcon board is these connectors are very tight. Even though it's a smaller board, you can't get your fingers in between any of these on either side. As with the HolidayCoro board, easy to pull these connectors off, no problems. You can see that they're very well labeled, so you can easily get to all of the plugs and see what their numbers are, very clearly displayed. You can barely see the numbering on the Falcon controller. Now, this also extends to fuses. If you're trying to pull a fuse, you have a hard time getting in there. You'll need some sort of device, such as pliers, to pull these fuses to check them because they're too tight against this. Now keep in mind, also, you got these wires that are normally going to be coming out this direction, and they're going to block these fuses, so they're already going to be harder to get to. Now, the AlphaPix, the Flex system has the fuses, and they're easy to get to. You can get your fingers across both sides easily to pull these out. No problems at all. Now, let's also look at our power input. You'll notice the power inputs on this Falcon are at the bottom. Now, given that we generally have power supplies located on the top, what we have to do is, if we have a power supply up here, we have to run the power all the way around. And that additional length from here all the way down to this bottom connections creates additional losses and extra wiring, and it just makes it less clean of a setup. And we'll show you a symbol controller using a Flex system and how much cleaner it is. So, also, the connectors themselves are better. So if you have to stack wires, this type of connector, or if you're using crimp terminals with spades, you can use those in this connector. So this is a much heavier duty connection, and they're all in one block, so they're much less likely to break off. As where the Falcon, you can see that it is quite movable, and sometimes these will break off. This is a connector we used to use in an older controller design, and we switched off of that in favor of these. Now, they both have power input status LEDs. Now, we see some other differences here. We see some chips at the top. These are buffer chips. The Flex-based system uses poly fuses, so you don't have to worry about blowing out your outputs. They are automatically like self-resetting breakers, so you don't have to worry about that. You don't have to replace these output chips and get stuck. Now, the Flex system does not have resistor banks, so if you're trying to adjust capacitance in wire, which is exceedingly uncommon, you cannot do that in this system. All right, now both have status indicators to blown LEDs, so they have lights that light up to show that the lights of the fuse may be blown, and they both turn on while they are operational. The light turns off when it is not operational. Okay, so those are the major differences between the SPI boards. Now, also note that our connector is on the back here, and that'll make an appearance here in a moment when we show you an assembled controller. So let's go on to the next type of device. Now, by the way, these are used for SPI type devices where you have a lot of outputs in one place. Typically, let's say, for example, a megatree. Now, you may want to combine a megatree and then go out and hit some other elements in your display, maybe like some arches in the front yard. Now, that means you need a long-range connection. Now, the long-range output controller, or long-range differential, has Cat5 connections that go out. Now, these are not Ethernet on either of these devices. These just simply use Cat5 cable to go from these long-range expansion boards out to receivers. So here's the comparable pieces. Now, these only have 4 plugs, but each plug results in 4 SPI outputs. So 4 strings of pixels can be hooked up to each of these boards. So again, these are really just the same equivalency of these with 16 outputs. It's just 4, 4, 4, 4. And then it's the 4 for each one. All right. Again, you have the same issues. You have this board with the section, and you have to adjust this jumper to select either 17 through 32 or 33 through 48, as where the AlphaPix does not need that. You also have a very, very small screw terminal. It's very hard to put connections in on this. All right. Now, we also have jacks here on the output. These are plastic as opposed to metal. And they're also going vertical. And you'll see why this is maybe not necessarily the best design. All right. Now, that comes out to one of these receivers. And so let's compare the receivers. So first is the fuses, again, kind of close together. They're a little bit harder, but at least you can grab on these Falcon receivers. You can grab them and pull them out on the sides. As where the HolidayCoro Flex system, you can grab them and pull them out on their flat, wide side here. All right, we again have these screw terminals because this does support up to 20 amps. You need a good power input connection, and then again, those are really superior to these screw type terminal connections, which can sometimes have issues. All right, they both have power input LEDs. Again, we have poly fuses on this as opposed to the blowable chips, and we have a metal connection for the jacking as opposed to plastic. Now these do have similar screw patterns, and there's a little bit larger size here on the HolidayCoro unit. Now these can be both mounted to our mounting kit, whether you have a Falcon or whether you have a HolidayCoro unit. And this is available. This is item number 642. Okay, now here's what's really unique here. This is the HolidayCoro 16 output AC controller. So this allows you, if you have legacy devices, to run the CPUs, either again the HinksPix Pro or the AlphaPix Evolution, with an AC controller. So you could take this off, be running Pixels, and then switch it over and it can run AC lights. So you have more expansion capabilities there. All right, so 3 expansion boards as versus 2. We believe that the expansion boards from HolidayCoro are a little more thought out and vertically stacking. So let's first show you a controller. So here's a controller. This is an assembled controller. This is in a 1500 enclosure, which is considered a small enclosure. And it has one power supply here. And it has the AlphaPix Evolution controller here at the top. And it has the expansion board for long range and SPI. This is all in one enclosure. Now, with a Falcon, you can see you can just barely get this controller in there. And we do make a mounting kit for this. And when we designed it, it was not easy to fit this in here. We fit this in here and still allowed you to get access to the screw terminals on the back of the enclosure. So, this method of going horizontal as opposed to vertical has a real disadvantage. And in this case, there is just no possible way you can get long range and SPI in a single enclosure like this, which is very common with a power supply. So, unless you're a Houdini, it can be a little hard to do. Now, this is also where some of these differences in these plugs come into play. So for here, we see that these long range connections come out to the top. But in this HolidayCoro assembled flex controller, you can see they come out horizontally. Why? Because we want all the cables to come out towards the bottom. That's where we're going. This is the top, this is the bottom. So we want all those cables coming out the bottom. So you can see how short the length of the cables, so you get the most amount of cable length coming out of the controller instead of having them go way up here or other locations. So we have very tight, clean insulation. We also have access to the fuses under here and the LEDs, so you can easily see them. They're not obscured by the wire. And we can easily plug into these long-range connections. You'll also see, because we have placed all of the power connections off to the right, even though we have a long range here, and we have an SPI board, you can see all the wires are as minimally short as possible. Now, let's also, now that we're looking at this, show you some differences in the way you access these controllers. So this have human interfaces, and you can see on the HolidayCoro AlphaPix Evolution and on the HinksPix Pro controller, we both have the same CPU arrangement, and this is compatible so that these are easy to replace because these can get damaged from time to time by damage or hitting. And so they're very inexpensive to replace this board, and they're not connected. So if you have a button go bad on your Falcon controller, you're out of luck. Good luck with that. But this, just pop that off, and you can replace that board for a few dollars. Now, you'll notice that these are very high on the board. They're the highest thing. They're above everything else. And that's so you can easily see them and you can easily get to them. You'll notice that they're in a nice star pattern and they're widely spaced apart. That's because if you're out in the middle of the winter trying to press these buttons with gloves on, you need some space. Or maybe you just got big old fingers and you need to be able to press these buttons easily. That spacing allows for that. Let's go here to the Falcon. You can see that they're almost placed underneath the display. They're very close together, they're hard to press, and they're way down here. You got all these wires and everything else that are going to be in here, very hard to get to. And the display's down here in the bottom. So this is all up at the top, easily accessible. Also, you'll notice the Ethernet cables have to come across your whole connection, as we're here, they're out of the way, they go horizontal, and they go right down here out of your controller, creating the shortest length possible. All right, so some of the fundamental differences, more of at a hardware level. So let's move up to more of a functionality level. All right, so let's compare functionality because we're dealing with 3 different CPU systems. The Falcon. Now this Falcon is shown here in the SPI version. There is a long-range 12 output port unit, which is pretty much basically 3 of these instead of those. Again, they're all built together, so you buy all or nothing. So it's not a mix and match system other than you can buy some ancillary. So it's sort of expandable, but not quite. All right, so let's start comparing more specifics. Now, they all have OLED screens, so they're the same size. They all have the same number of buttons for control, which is 5. They all use basically the same pattern. Again, we've talked about how close these are. And they all use, when we go to the connections, Phoenix pluggable connectors, and they're all fused. Again, let's move up here. We also have network interfaces. These have Ethernet 100 megabit connections, and they are network switches, as is the HinksPix Pro. It's also 100 megabit, and the Falcon is. Now, some differences that start to show up now is the number of RS-45 ports. So there are 3 plus an extra one on here, 4, and 1 on the HinksPix Pro, 2 on the AlphaPix Evolution. Now that's probably mostly based upon the fact that these are, this is the oldest controller, second oldest controller, and the newest controller just released. So this is nearly 2 years older than this controller, and it reflects the reduction in reliance on RS-45 based technologies and a move to more Ethernet modern technologies, hence the dropping of those RS-45 ports. Now, the AlphaPix Evolution is a very more basic controller, and it does not have Wi-Fi. So there is a Wi-Fi interface on the HinksPix Pro, and there is a Wi-Fi interface on the Falcon. Now, I should mention that the Falcon interface has a choke point because of its interface going to its CPU. So this is effectively not really useful for anything other than accessing the web interface. Now, the HinksPix Pro has more bandwidth. There's always a limit with wireless compared to wired. There is less of a limit in terms of bandwidth on the HinksPix Pro Wi-Fi, and you can stream data to or access its web interface or have point-to-point synchronization. Now, we do have some other similarities. We have a fan connection on the AlphaPix Evolution, and we have a fan connection on the Falcon controller. Now, we actually don't even recommend fans because we actually have more problems with fans than no fans. They generally suck in water, moisture, bugs, dust, other problems, and hence, as we've evolved these controllers, we've just dropped the fans because a properly designed system won't have that, because all of these units have temperature sensors, and they will throttle output or turn off the control output if they are over temp. So these already have safeties built into them. So a fan generally is just not necessary. As I mentioned, they do have temperature in them, in all of them. They also have temperature in addition to the voltage. So voltage can be monitored on the devices to see what the voltage feeding these devices are. All right, now, let's talk a little bit about history because there is some interesting history here. So this is the HinksPix Pro 3, and the original HinksPix Pro, released in 2016, was an industry leader. It brought out the network switch, had wireless, and an SD card built into it, along with a real-time clock. Now, along came the Falcon V3, and it was a kind of a copy of that. It incorporated Wi-Fi, it incorporated the network switch, and it attempted to incorporate the Play on controller, hence the SD cards slots here. Now, that was originally because this HinksPix Pro was designed to be able to be standalone playback. Now, the Falcon ultimately didn't implement that functionality, so there isn't a playback functionality. When a Falcon person typically uses playback functionality, they use a separate device that you can purchase for $100 or so, adding on to this and configure it. And it then adds an extra level of complexity. So it's a whole standalone Falcon Pi player that's separate of this, so it does not have play on controller functionality. So what does that mean? That means if you want to do really advanced, complex mesh network type shows where you have multiple controllers all talking to one another, kept in sync over Wi-Fi, this HinksPix Pro is your choice here. It can do that via Wi-Fi and simply send data back and forth between a master controller and a slave controller, and that allows you to take sequences either from EasyLights.com or upload it from Xlights through a conversion tool and play them on the controller. That also means that we need a playback functionality, and so we have a battery for real-time clock so we can schedule the shows. And that means we also have an audio connector. Now this audio connector actually works. Now there is an audio connection here, but again, all that functionality, while copied from the original HinksPix, did not actually make it into functionality in terms of firmware. So we do have an audio jack, 1/8 inch output, and that drives audio. Now, if you want some additional functionality, you can purchase a fully FCC certified FM transmitter card. Just simply plug this in. This is less expensive than the typical $125 whole house type transmitter, and this will transmit FM, and it's fully configurable from the controller itself. And so this can drive FM and audio output directly from this device. So the major differences there are going to be play on controller, as where you would have to purchase that separately and then wire the controllers between each other. So this concludes our assessment of the differences between the Falcon V3 system and the HolidayCoro FlexBase system.